Hi everyone, I am Aditya Shaw, 20MIC0118. Today I am here to discuss about our project, GIFinity, a creative and immutable blockchain experience, and rest all are my teammates. And today we'll be talking about our project, uh, starting with Aryan.
Okay. Hello, I'm Aryan Tiwari with my registration number 20MIC0164. And now we have the topic on the project, that is GIFinity, a creative and immutable blockchain experience. GIFinity empowers users to send transactions uh, through the Ethereum blockchain securely, while also allowing them to pay each transaction with the GIF. GIFinity bridges the gap between the immutable world of blockchain technology and the dynamic realm of creativity and personalization. GIFinity connects seamlessly to Ethereum through MetaMask, providing users with a secure and direct link through the digital wallet. It leverages HADDAT for smart contract development, testing, ensuring the reliability and security for every transaction. Now we'll discuss on the important applications of the project. Immutable data storage. Blockchain's key feature is immutability. Once data is recorded on the blockchain, it cannot be altered or deleted. Transparency and trust. Blockchain is a distributed ledger, meaning every participant in network can access and verify the data. Decentralization. The application leverages the decentralized nature of blockchain. Users have more control over the data and transactions. Integration with Ethereum and MetaMask. By connecting your application to Ethereum via MetaMask, you empower users to interact with the blockchain directly from their browsers. Apart from that, user engagement with GIFs. Pairing transactions with GIFs add a creative and engaging element to the application. Use of HARDAT for smart contracts. Using HARDAT for smart contract development and testing ensures reliability and security. It allows you to create, deploy, and test smart contracts on Ethereum's network before deploying them, reducing the risk of errors and vulnerabilities.
Greetings everyone, my name is Miratim. My registration number is 20MIC25. Allow me to talk about the papers that we have undertaken, the papers that we have studied for this project. We have to study at least 5 to 6 papers. Presently, I'll be discussing only just 2 papers. The first paper was published in 2021. Ben Wong and associated authors. The title of the paper was a research application of smart contract based on Ethereum blockchain. The primary methodology that they adopted was smart contracts that were based on Ethereum blockchain. The key features of this paper were we studied about structure of Merkle-Patricia tree, consensus algorithms, and the structure of Ethereum and operation logic of smart contracts. There were some challenges that we were able to identify in the paper. The challenges were issues of the current application that were not fixed completely. The other paper that we studied was written by Arnold Laurent with associated authors. Paper was published in 2022. The primary methodology was Ethereum-based transaction models. The key features of this paper that we noticed were the design, implementation, and testing of smart contracts in Ethereum blockchain. Some of the challenges that were faced in the challenge that we noticed in the paper were the gas fee transaction in Ethereum that is likely very high. Uh, which is also one of the reasons why Ethereum is one of some of the least preferred platforms. Next slide, please. There are obviously the papers that you study will provide us some gaps. There are gaps in the literature survey that we have done. Let me summarize those gaps. What are the shortcomings of all the papers that we have studied? The first shortcoming that I found was high transaction costs. One of the most pressing features in Ethereum is obviously the high uh, cost of gas fee. We know that gas fees are the fees that users pay for processing transactions and executing smart contracts on an Ethereum network. The other issues that we found out were scalability challenges. Ethereum scalability issues have contributed to high gas fees. The network's current consensus mechanism, that is proof of stake, is being implemented to improve the scalability. There are also unpredictable costs. Gas fees are not fixed, they fluctuate based on the network's demand. So, this makes it difficult for users to predict how much they will pay for transactions, potentially leading to unexpected expenses. There's also the challenge of network congestion that we found in many of the papers. When the Ethereum network experiences a high traffic, transactions can be delayed or sometimes even fail to process. This can be frustrating for users and for distributed app developers all alike. There are also economic barriers. We have talked about high transaction costs. We've talked about unpredictable costs so far. Economic barriers, when obviously high gas fees are levied, they can create economic barriers, limiting participation of the in decentralized finance and NFT ecosystems. These were some of the gaps that we have found in the literature survey. So we hope to read more papers and implement more mechanisms that will help in addressing all these issues.
Thank you, Adeem. Now let's focus on the sample problem statement. So the problem statement is develop a secure Ethereum storage and transfer the application utilization, the smart contracts and the MetaMask integration. So the addresses the challenge, like we address the challenge of the high fees, limited accessibility and intermediaries in traditional financial system. Like there is always some in between the company or the developer who charge the transaction of the gas fees. So aim is to promote the financial inclusion, transparency, and decentralization, offering users a user-friendly and cost-effective solution for managing their Ethereum holdings. And the next slide. So the sample objectives are like first, enhance user engagement. Like we are sending the gifts with the transaction, so it's increasing the user interaction and enhancing their experience. And the other objective is ensure data immutability. Like we can't delete or enter the data. So after the transaction, all the data will be stored in the blocks, and with the GIF, the data will be stored in the blocks. And promote transparency. So it is basically useful for verifying the authenticity, because everyone can see the history of the transaction and they can verify accordingly. And facilitate trustless transaction. As I told before, there is no intermediary, so it promote peer-to-peer interaction. And harness smart contracts, like we are implementing through the smart contracts. uh, it will increase the efficiency and reduce the risk of error. Also, we are introducing like one objective of like we will notify of gas cost of the gas, so the user can see the gas cost of the gas and estimate that when will they do the transaction, so that they got the less transaction fees. So these are the objectives.
Current implementation. So what we have done is we have introduced smart contracts, uh, which uh, uh, which which completes the transaction when certain rules are met. And we have also implemented a, we have also implemented when a user can look at what the current gas fees is, or what the current gas fees is. For example, if a user want to do a transaction currently and the gas fees is very high, so he can postpone the transaction. We use an API called Block Native API, which shows the real-time gas fees, and we also notify the user when the gas fees is a little bit low, or it touches the mark that the user want us to touch. And let's discuss what's happening in our architecture. So the user interacts with the uh, interface, and then he connects to his MetaMask wallet using the MetaMask integration. So the front end handles authentication indirectly through MetaMask. User connects their wallets, which are authenticated within MetaMask, and front end gains access to the Ethereum wallets. And then we look at the API request. The front end communicates with the backend, making HTTP requests to a specific API endpoints. These requests are used for tasks such as sending transaction data, fetching transaction history, and other more services. So to send a transaction from one wallet to another wallet, user has to give the information about the account number of the other MetaMask wallet, and they need to give a text and also a message included in that, which will be updated in the Ethereum blockchain later on. So what happens in the blockchain in the backend? So in backend, we interact with Ethereum using the library called Ethers. It creates an Ethereum contract instance, sends transaction to the smart contract, and queries transaction data from the blockchain. Now, transaction processing, how does it happen? The backend processes the transactions requests, send them to the Ethernet network, and waits for the transaction confirmation. It also updates data based on the results of these transactions. And moreover, we are using another API called GIF API. What it does is it integrates our current existing it updates our transaction with these gifts. It integrates the transaction with these gifts. So when the transaction gets stored in the Ethereum blockchain, it gets stored in the form of these gifts with some additional message attached to it. And yeah. So let's have a basic look at the transaction flow. So user connect to their MetaMask wallet. User initiates transaction through front end, including the input transaction details and signing with MetaMask. The front end sends transaction data to the backend through API requests. The backend processes transaction, interacts with Ethereum smart contracts, and wait for confirmation. Upon confirmation, the backend data updates its data. User can view transaction history and associates GIFs through front end. Yeah, so basically, we have may, made the problem of gas fees a little bit less problematic to the user. They can do the transaction when the gas fees is at their minimum. And we have made it more user friendly by integrating it with gifts, and we have made it more faster uh, by using smart contracts. So let's look at the technologies that we have used. We have used React.js for front-end and Node.js too, and we have used MetaMask for storing the wallet, Hardhat for testing of our smart contracts, and Solidity to program these smart contracts, and Tailwind CSS for stylings. These are the hardware requirements. We require computer, processor, RAM, storage, and GPU. Software requirements are in a development environment, Node.js, memory, Hardhat, Solidity compiler, MetaMask, version control system, testing frameworks, and we can use Git for the version control system. And continuing with Dharya.
So the national status, the national counterpart of our application would be WazirX. The main purpose of this application is to have a secure wallet, INR trading pairs, and peer-to-peer trading. The main features of WazirX, if to begin with, would be to start with the lowest price, get the account verified within 2 to 4 hours, and to be user-friendly to beginners, and trade all altcoins directly. Next slide. There would be some loopholes in this WazirX application, which would be impersonation having a percentage share of 34.7%, phishing and airdrop scams having a percentage share of 21.1%, Ponzi scheme and social engineering scams of 40%, and some others include a percentage share of 4.2%. Some pros of this application would be it is India's first automated peer-to-peer trading platform, friendly customer service, and 95% of the finds are stored in cold storage. On the other hand, some cons would be it lacks some margin trading and it only supports 8 coins by peer-to-peer. The international counterpart would be Binance. The major features of Binance would be meager trading fees of just 0.1%, instant account verification, user-friendly for newcomers and experts alike, and 95% of the cold storage. And 95% of the cold storage to keep your crypto extra secure. Next slide. The advantages of this Binance application includes that there are a few fees compared to other exchanges, 25% off trading fees if you pay with Binance Coin, and available education resources. On the other hand, the disadvantages would include that it is not available in all the states and lack of information on security. So, in conclusion, if I have to say, GIFinity is a fusion of creativity and blockchain technology. It offers a unique and engaging platform to play the transaction with GIFs, making blockchain interaction personal and memorable. By seamlessly integrating with MetaMask and leveraging Ethereum's immutable ledger, GIFinity ensures the security and permanence of these interactions. Thank you.